Now in waves, we have transverse and longitudinal waves. You can imagine that transverse waves is the wave of the object sideways, like either right or left or up and down. So you can see this guy here, chain style line, that each one of these parts of the chain are connected together with a little degree of freedom or freedom to move right and left. So when he swing the rope right and left, the rope will start to swing in a snake style, and he can pull it up and down, and you can see there's a wave being generated in the y direction, or you can do it in the x direction. Both of these are considered a transverse pulses or transverse waves. While when you have longitudinal wave, imagine you have a spring, you push it forward and the spring will bounce back and forth. Any motion that is parallel to the axis of the object, that's called longitudinal waves. And as I said, for the rope, in most cases you have transverse waves that are going sideways, either on x direction or on the y direction. So we can define the transverse pulses. A pulse moving through a spring is a good introduction to the way the wave moves through a medium. Ideal spring is one that allows pulse to travel through it without the loss of energy. So the pulse is just the positive hump or the negative hump of the wave. Its length is 1/2 the wavelength. The spring provides a medium in which the motion of pulse can be observed from the side. The spring is in equilibrium position at first, then when you flip the spring sharply to the side and back, the motion of your hand sets up a series of sequential motions in the coil of the spring or in the chain. Each coil imitates and turn, and the motion of the hand will be translated to that coil or that chain. So this makes transverse pulses, while if you have the coil spring and you push it forward and backward, he will start to bounce back and forth parallel to his axis, and that way would be longitudinal wave. So this is a little explanation what's going on in terms of velocity and amplitude. So in your hand, you're holding a chain or a certain spring with low stiffness, and you bounce it up. That's what we call a pulse. You give it an initial force or initial velocity. So your hand give it a velocity upwards. Now the pulse will translate all the way to the end of the spring. So here you have the velocity of hand 0. Here you have velocity of hand at a certain value, and here at the top velocity is 0 but the amplitude is a. Then you push it downwards as well, so you create a pulse with a length L. In this case, the pulse will go all the way to the end of the spring. Here we have a little flash game that is representing the transverse pulses and the transverse waves. So you have here a series of joints, or let's say we have a chain, or you can consider it as a spring. This side of the spring is fixed while this side is free. So in your hand, you hold the tool over here or the wrench and you give it a pulse. The pulse will translate all the way to the end. So if we do it again, give it a full pulse up and down, up and down. So the wave translated all the way to the fixed side and it will hit the barrier and bounce back. So you can repeat that over and over again. You can see here you give it a certain velocity and you stop here. Like let's say you go here, 0 velocity, then you go down, 0 velocity again. So you create a wave. That makes sense. So just a little bit of explanation, visual explanation for you about the transverse waves that could make things more visual and more understandable for you. Now, what's the relation between waves and energy along the pulse? When you create a pulse on the spring or the chain, the energy is stored in the form of elastic potential energy and kinetic energy. Both of these, it will transfer from one shape to another. So as a section of the spring moves from the equilibrium position to the top of the pulse, the section has kinetic energy that's moving sideways relative to the direction of the pulse, and elastic potential energy that's stretched sideways. So at the point on the pulse where the displacement is greatest, the coils are, for instance, motionless. So then the tension in the spring returns the coil to their equilibrium position. So if you analyze, it is simple. You create a pulse, the pulse is moving here. So at the top here, the kinetic energy is 0, but the potential energy is maximum. Then here you start to have kinetic energy is increasing and potential energy is decreasing, and when you go down pulse, potential energy will be max, kinetic energy will be zero. It's kind of, the motion is you have a momentarily stops when you have the wave being on top, then the wave will go down and up. It will be flipping between zero kinetic energy, maximum potential energy, and less potential energy and higher kinetic energy to transfer the wave or the energy from one section of the spring to the next one, and so on. You have a reflection for the pulses that happens when you have a fixed end for the spring or for the chain. You make a pulse and the wave is moving. Now the wave wanna bounce back. When it bounces back, the wave will be an inverted shape of the original pulse or the original wave. So the original wave was going in the positive top side. Now it's going to the negative top side. So you can see the wave is fully inverted between the incident pulse or the energy pulse, the pulse that is being generated by an outer source or an external force, and you have the reflected pulse as a reply for the force being hit by a barrier and going backward with a certain velocity v.